Now, in order to write the equation for bridge circuit, just by seeing the figure, for most of the bridge circuit, just by seeing the figure, consider R resistance as R, L inductance as L, and C capacitance as 1 upon C. While writing the balanced equation Z1 by Z3 is equal to Z2 divided by Z4. For example, consider this Maxwell inductance bridge. Here you have R1, R3, L3, Rx, Lx and R2. This is for measuring the inductance Lx, and Rx is the resistance of the inductance. This is not a pure inductor, it has some value of resistance. In order to measure the Rx value, write the equation R1 divided by R3 is equal to R2 divided by Rx, because I consider Z is equal to R. Okay. Now for finding the value of Lx, consider L as L. So here Z1 will be R and Z2 will be R2. Here you will have Lx and here you will have L3. So Lx would be L3 into ratio of R1 and R2, and Rx would be R3 into ratio of R2 and R1. This is the Maxwell inductance capacitance bridge. The earlier one was the Maxwell inductance and this was the Maxwell inductance capacitance, wherein you will get the inductance L consisting of capacitor and resistor, okay, as a function of capacitor and resistor. So this is known as Maxwell inductance capacitance or Maxwell Vein bridge. Okay, here in order to write the equation for Rx, consider this equation R1 divided by R3 is equal to R2 divided by Rx, and in order to write the equation for Lx, consider C as 1 upon C and L as L. So you have 1 upon C divided by R3 is equal to R2 divided by Lx. So you have Lx is equal to C into R2 into R3. This circuit, now this is an Anderson bridge. The Anderson bridge actually consists of a capacitor here and a resistor here R, and this galvanometer is connected to this point. So this is connected to this point and this is not there, but and this is what, this is R4 and this is R2. This is capacitance C and this is smaller r. But after solving this equation, you get these values as the delta of what? Resistance R, the star of resistance R, R4 and R2. This becomes what? This becomes R6 and this is what? R5, and here there will be galvanometer. So wherein the R5 is equal to R3 plus R plus R3 divided by R4 into R. Okay, so this is the equation. Now in order to write the equation for the final circuit of Anderson bridge, again you have to consider R as R, L as L and C as 1 by C. So in order to write equation for Rx, you have Rx divided by R3 is equal to R5 divided by R6. And in order to write equation for Lx, you have Lx divided by R3 is equal to R5 divided by 1 by C. So Lx is equal to R5 into R3 into C, where R5 is what? R3 plus R plus R3 by R4 into R. Now this is the Owens bridge. This is also used to measure the value of inductance, unknown inductance Lx. So before writing equation for this circuit, you have to consider that if you take, in order to write equation for Rx, here you will take Rx and R3, but here you can also take R2 or 1 by C2 and 1 by C4. If you take R2, then this equation will be ohm divided by ohm is equal to ohm divided by 1 by Faraday, which doesn't work. So for Rx, you have to take Rx by R3 is equal to 1 by C2 and 1 by C4. This is equal to C4 by C2. So Lx by R3 is equal to R2 divided by 1 by C4. So Lx is equal to R2 into R3 into. Now in order to find the equation for sharing bridge, which is used for capacitance measurement, for Rx we have to use 1 upon C1 by 1 upon C3 is equal to R2 by Rx. So you have Rx is equal to R2 into C1 by C3, and for Cx you have to use R1 divided by 1 upon C3 is equal to R2 divided by 1 upon Cx. So you have C3 R1 is equal to Cx into R2. So Cx is what? C3 into R1 by R2. And similarly for D Shortridge bridge, you can write the equation 1 upon C1 by R3 is equal to 1 upon C2 by R4. So if C1 is the unknown, then C1 R3 is equal to C2 R4. So C1 will be 1 by R3 into R4 into C2. Shortcut wherein you can use the R as R, L as L, and C as 1 by C cannot be applied to Wien bridge and Hayes bridge. The Wien bridge is used to measure the frequency and the Hayes bridge is used to measure the inductance. So these are the exceptions, and but I think that this shortcut will be very useful in the sums wherein the bridge circuits are not of these types. Which types? Like the C and C are in series with each other, or this like H step, okay. But for other circuits you can easily apply this rule and you can get the equation.